All right. Well, welcome. Thanks for having me. Hello to whoever's online and those of us here. I'm Mike Puckett. I work for SolidWorks Corporation. I've been with the company for about 10 years. This is my 10th year, and I've always worked on the certification team. We were discussing a little bit before everybody joined in with us. I used to use the software to design plastic injection molds back in the day. Started using the software late 1998, 99 in that time frame. And then joined the company in 2009, January 2009, and been with them ever since. So we have a couple of hours together today, which should be plenty of time to get through everything we want to get through. So just to give you an overview of what we're going to do, just got a quick presentation about how to access the exam and how to get it for free. So we're going to give you guys a code to be able to take it for free. If at any time in the future you guys want to take it and you need another code, you guys can always contact me through Monty or Lars here at this location, and we can facilitate that. So once we go through that, I promise just really quick, about 5 minutes, we'll get into SolidWorks and we'll start actually modeling some parts. All right, so I don't want to spend too much time outside the software. So the customer program, when we talk about the customer program, these are the exams that we have available to users today. All right, so it numbers about 14 topics in total, and we localize that around the world into up to 15 languages. The newest one that we just added was for additive manufacturing. So basically 3D printing is a new associate level exam. And we basically have 3 levels: associate, which is the entry level or kind of like basic kind of exam content; professional, which is the CSWP, which is what we're going to be talking about today; and then expert. So we have associate and professional exams in for different types of topics. But for expert, for right now, all we have is just mechanical design. To give you guys some insight into what we're doing, we're hoping to have an expert level simulation exam available to launch early next year. So if anybody's into FEA and stuff like that, that's kind of basically who that's going to be targeted at. So here's the offer that we're going to do. This is this process is rather straightforward. Okay, so there's a code here. I can pass this code off to somebody to distribute a little bit easier, in case you can't screenshot it or take a picture or write it down right now. Basically what this does is you're going to want to go to this site, virtualtester.com, and download a client. Unfortunately, it's only Windows-based at this point, so you need a Windows computer to run the client. And you'll register. I'll walk you through the process, and you're going to take this code and redeem it. Now, what this code is going to do, it doesn't mean that you have to take the exam right away. Okay, but there is an expiration date of May 25th. So what this does, this code is just basically it's gonna deposit credits into the account that you make, and then it's gonna leave those credits in there forever. And the credits are good to take the CSWP or the professional level mechanical design exam. Now again, these credits, they never expire, they'll always be there. Even when we revision the exam and we put it to the next revision, like we just did back in January, the credits are converted to work with the new exam as well. So you're going to want that code and that website. Once you download the client and use it, or and have it open, you get to a screen like this. Is basically just simple account creation. First name, last name, email address are the things. Those are the things that you're going to want to type in correctly. Address, company, everything else is not super necessary. You can put in what you want. We do have an online directory, so putting in your location might be worth it in case you want to be found or be listed in the correct area. Once you get through that portion, you'll get to this page here, and there's a box down there. It says event ID or voucher code. That's where you're going to plug that code into. So you type it in, click submit, and it's going to tell you that it was redeemed and you have credits in your account. And that's it. You just have to do that before Friday the 25th, and then come back at any point in time to take the exam. Okay? So that's it on that portion of it. All right. So I'll give you these. The way to contact us if you need assistance with that code or something else. Certification at solidworks.com is the easiest way to reach us. The guys on my team monitor that inbox nonstop pretty much. So usually if you send an email, you usually get an answer back within an hour. So the guys are pretty on top of things. And then solidworks.com certification is that's our spot on the internet, our web, if you will. So let's switch over to the topic that we're all kind of here for today. And this is the CSWP Prep. So this is largely based on, or what is actually 100% based on our sample exam. All right, so you can go to this website, solidworks.com/CSWP, and there's a sample exam that you can download. It's a 32-page PDF file. but most of it talks about how to create your account and all this other stuff. And then about 10 or 15 pages of it is actually what we're going to go through today. So if you're following along today and you want to do it on your own, you can always go do this afterwards. And it's free and it's there, and it actually uses the tester client. So it helps you get used to how to use the client as well. Basically, what we're going to do is we're going to build this part. Okay. What I'll do is I'll thumb through it. We're going to build this part. And the way the exam works, this is based off the very first part of the exam. Okay, we don't have the ability to see how you guys model something in terms of features, all right? But if you have like we were discussing at lunch, if you have a cup, all right? Imagine just a simple like plastic cup. There's probably a few different ways to design that, model that cup in SolidWorks, right? You can do an extrude, you could do surfaces if you want. You could do extrudes on top of extrudes, but the simplest way is probably just a revolve, right? And you could do it in one feature. Each way, maybe one way we would say is better than another, but certainly one way is going to be more efficient than the others, right? So we try to aim at finding the most efficient way to model something, and that's where the time limit comes into the exam. So if you're modeling in an efficient way in SolidWorks, our thought process is that you should be able to complete the exam in the time allotted. If you're just kind of patching things together and piecing things together, well, you're going to run out of time. You know, not to pick on Monty for running out of time, but so, but that's basically how we do it. To see how if you're answering it correctly, again, we can't look at the actual geometry that you guys are creating. We have you create a model like this that's shown on the screen, and then you apply a material, and we ask you how much it weighs, right? If you model a 1 by 1 by 1 cube that's solid and assign a certain material to it, it's going to have a weight that's never going to change. It's always going to be the same weight no matter what, right? So on this part, if you're missing things, like let's say you missed the chamfers, these 4 by 2 millimeter or chamfers down here, that's going to affect the weight of the part, right? Now, we typically tend to do tricky things like if you exclude these chamfers, we'll put that weight as one of the options of the answers, right? To not trick you, but just to maybe lead you down the wrong path. But so it's always important to pay attention to the drawings, okay, that we provide you. On this screen that you can see here, the red arrows point to the variables, right? So what we do is we have an API that we run. We model this part, and then we have an API that we run inside SolidWorks, and we choose 5 or 6 dimensions, and we tell it, okay, take this dimension and give us a variable at every X amount of steps. And then it spits out basically 500 iterations of this model that we can then copy and paste into our tester tool and create 500 versions of this model in just a matter of minutes. All right, so that's one of the reasons that we use variables there. So if you're taking the exam sitting next to somebody, be very careful that they look the same because the values are going to be different. All right, so just take those in considerations. In the tester client itself, so the text that you see over here on the left side of the screen, this is basically how the text appears in the tester client. Okay, we tend to try and give you more information than you actually need. Okay, our goal is not to test you on your ability to take an exam. We want to test you on the ability to model stuff in SolidWorks. Okay, so we try to be very clear on there. We try to show if there's changes or call out different things. So we're very clear. The drawings usually have more than enough information, but sometimes you have to look and see where things are called out. So there isn't really any sort of drawing standard used here on the tools or on the exams. We try to just make it very clear. So in the case of this part that we're going to build, you'll see over here that'll say this is stage 1. You're going to build this part. It's going to give you the unit system. We're a global company, so every model you're going to build is going to be in millimeters, grams, and seconds. Okay. The nice thing about that is it's all whole numbers. There's no fractional numbers or decimal numbers, stuff like that. It's all whole numbers. Decimal places is going to be in 2. So as you're modeling things, you're going to get some dimensions that might go out 3 or 4 places. But we round everything off to 2 places. And then on top of that, the answers that when you provide an answer, when you type in an answer, we usually have an allowance of about 2 to 5%. Okay, so we actually allow to have a little bit of error there. We give you the part origin. Okay, so on a part like this, where it's just a simple part, all we're going to ask you for is the weight. The center of gravity doesn't matter on this part. Okay, in an assembly, we'll ask you to assemble some parts, create some mates, then we'll ask you where the center of gravity is. Right? So if the parts are not mated correctly, it'll throw off that center of gravity. Okay, so on this one, it's arbitrary. This materials you see is called out as alloy steel. We always use very basic materials, either alloy steel, brass. I think there might be a couple that are copper, right? But we don't use any weird materials that are, 5 layers down in some materials folder or something like that. It's always just really easy to use ones. And then the default material properties we leave alone. We don't change. We do call it out just so you can double check, but we don't change any of that stuff there. And then basically, this is the context or the content of the question itself. So it's basically telling you to create this model using these variables for this part. And then what it's going to do is it's going to ask you what's the mass of this part in grams. Okay, so pretty straightforward, all right? We do give, there is some time, I think it says about 10 minutes to model, 10 or 15 minutes to model this part. Okay, I think this exercise online gives you about half an hour. So what we're going to do is we're going to model this part, and then we're going to update some of those variables. And they're going to, so in this first one, it'll ask you, here's multiple choice, gives you 4 answers. You pick one. So the nice thing is if your model weighs exactly one of these numbers, you're dead on, right? But the next 2 iterations of it, where we change some of the variables, there may no longer be a multiple choice. You have to enter in the value. All right, so now is when you start, if you're wrong the next time, now you start down a road that you just basically won't be able to recover from, right? And you won't know it until you get the exam graded. So you'll notice that on these, we will be off slightly, like 0.01 or so, 0.02 maybe. We don't know why. We think maybe it's something with the way the kernel is kind of progressed over the years, but there's a little bit of difference there, but nothing negligible. What you're looking for is if you're off like in the, in like the whole numbers, if you're off 1 or 2, 3 grams, there might be an issue there. You're missing something. In my experience in doing this presentation, I've done this about maybe 10 times now. I've missed some things here or there, but the fun part about that is that as a group, we can go back and try to see what we're missing. Okay. And pick those things up. The last caveat I have before we start modeling this part is that the way I'm going to model this part today is going to be different than any of you guys will model it. And that's okay. All right. The way that I put features in place or the way that I do things, I think one of the best ways to learn SolidWorks is to watch other people use the software. Okay, that's how I learned years ago. That's why I love going to SolidWorks World and seeing and watching the presentations, because you just always grab tips and tricks that people use. Okay, as we go through, I'll explain what we're doing. So this is going to take us way longer than a half an hour because I'm going to stop and explain things as we go along. If anybody has questions in the room here, raise your hand. I'm not sure how we take questions online, but
We do have people that are online.
Okay. Okay, let us know. Yeah. So again, and then as we're going through this, I love small groups like this because we can do whatever we want, and there's not 40 people like that we have to keep happy. We can try different things. So if you see that I model something and say, well, how about trying it this way? I'm more than happy to back up and try that. Okay. And if you have a question, say, well, how did you do that? Just raise your hand and we'll go from there. So let's jump into SolidWorks and just start a new part. So again, this is going to be a metric part because all the numbers are metric. So I'm going to use my millimeter template that I already have set up. And these templates go way back to probably 2002 or so. I've been kind of using these templates and just carrying them on over the years and updating them. So I'm going to try and tab back and forth between these two so we can see what we're doing. I have the drawings in front of me, so I don't have to keep switching back and forth, making people dizzy on the screen and stuff like that. So I do have them here, my cheat sheets here. When I look at this part, the first thing I see is that everything is kind of dimensioned off this corner for the most part. So that's where I'm going to put my origin. It doesn't really matter in the sense of answering the question on here, but since everything is referenced off there, it makes it easier to dimension. So there might be design intent as well, and I don't know of. Okay, that's assumed like there's some industrial design guy that came up with this, and this is how he wants it modeled. So that's how we'll model it. So we'll start there, and I'm going to just start basically by sketching on my top plane. You'll see that I use a lot of shortcuts in the software. All right, so at SolidWorks, our goal is to keep your mouse inside the graphics area. And the usability team actually does these studies where they'll record mouse movements of a user for a few hours and see where they're going out of there and see how they can fix it. So I use a lot of shortcut tools. My favorite is the S key or the shortcut toolbar. Okay, that's basically like when I'm in a sketch, I just hit the S key on my keyboard, and I have this menu that pops up, the toolbar that pops up. Now, this shortcut toolbar is configurable in 4 different areas of the software: sketch, parts, assemblies, and drawings. Okay, so depending where I'm at, when I hit S, it gives me different tools. Okay, another popular one that people like is the middle mouse button. I'm sorry, the right mouse button and this little wheel that comes up. I'm not a super huge fan of it. And at one point I had all of these buttons mapped to the S key. And so I could just quickly hit that and then my S key would pop up. So I loved when the S key came out when I was a user, and I've kind of stuck with it since then. So I'm just going to grab my corner rectangle tool here, and we'll start on the origin and just drag over to the left. And then, so now is when I'm going to start dimensioning it, all right? But let me take, we'll pause here for a second. And if we go back and we look at that drawing, we have variables that we need to put in, okay? Now, on the exam, these variables may or may not change through the iterations of the exam. So you can type these in every time if you want, and and feel confident that you're grabbing them all, because as you can see here on the drawing, like dimension C is used a couple of times, A and B are only used once, E is used a couple times, and X and Y are only used once. So feel free to avoid variables if you want, okay? But it's a time saver, all right? The same thing with the equations. Down here, what we do for variable Y is actually B divided by 3 plus 10. Now, I'm sure everyone's really good at math, but if the software could do it all for you, why take the time and risk doing that? Okay, so I'm going to show you a couple of different ways to set these up. All right, so the outside dimensions are, it's A in this direction, and it's B across this dimension or down there, all right? So what I'm going to do is I'm going to just grab my dimension key, and I'm going to just drop a dimension here. Now, this is a variable, and this is A. So what I'm going to do is I'm going to type equals, quote, A, quote, and it's going to ask me, do you want to create a global variable named A? Sure. Okay. And now I type that variable in, and that variable for this setting is 213 millimeters. Okay. So there's my first variable. All right. Let's see if we can get into the equations. Let me exit the sketch just right now, just to show you what that did. We right click on the equations here and go manage equations. We can see that the global variable of A was placed in there for us automatically. Okay, so that's a quick way to add global variables. And I didn't know this the first few times I did the presentation, and somebody said, hey, try this and see if it works. And it did. So while we're here, I'll show you how to do the other ways, or to input it here. So basically what you can do is you can just right click on the equations folder and manage equations. So for here, we'll just type in B and then hit the tab key, and that's going to be 200. And then enter, and you'll see what where it evaluates to. That's the answer there. So we'll finish typing these in. This is C is 170. D is going to be 130. E is 41. And let's see, F is actually a whole wizard call out. So it tells us what the screw type should be. So obviously that's not a variable in the sense that where we can plug it in here, but it's just telling us what it is. So the next one is X. And this is our first equation. Okay, so on the sheet, it shows us X is A divided by 3. So basically, I'm just going to click here, global variables. I'm going to grab A divided by 3 and then hit enter. Okay, and it gives me the evaluated number there. And then our last one is Y. And that's going to be B divided by 3. So it's B divided by 3 and then plus 10. Okay, so there's my variables and my 2 equations that I have. And that's it. They're set. Okay, I don't have to worry about them anymore. So let's go back into our sketch. We already have the A dimension set over here. So now this is the B dimension. So to grab that, since we've set the variable in our variable or equations manager, all I have to type here now is equals quote B quote, and then enter twice. Right? Now after we submit the first answer and the variables change the next iteration, all I have to do is go back into the equations and change those values. And then when I hit OK, the whole model updates. So in just a few inputs of numbers, it'll change on it. And we'll see that as we get to this model. So there's the base of my model. The extrude thickness, as we can see on the drawing here, there's a couple different areas. So if we look over here, it's 35, but that's just that little tab area. Okay, the rest of it is at 25. My brain tells me to just extrude it at 25 and then add that other boss later on. It's easier than trying to go all the way up and then cutting the rest of the area down, right? Seems simple enough.
Can I ask a question?
Yeah.
Will the equations stay specific to different configurations? If you change a configuration, will the equations be able to be changed within that configuration? Or are they across the board? Say you have like 2 or 3 different configurations in the part?
You can configure, you can do either or. So I think by default, they'll carry over, but then you can configure them for each configuration as well. The tool to use it is really cool. When you have multiple configurations, you can configure, I think you right click and configure dimension. It's somewhere in there where you configure the dimensions and you can type, you'll see all the configurations and you can change it for each one. And then there's actually a rebuild light in there and you can click it and it'll go through and generate them all to make sure there's not going to be any errors. And it'll show you if like if you put one of them that's just way out of the range and it's going to cause the model to fail, it'll show you there's an error. So yeah, you can, it's configure dimensions is the best way to do it. But I think by default, it'll just carry across. If I make a configuration of this, they'll be there for that.
So like if I have the second configuration, I can go in there and change the equations and they won't affect the first.
Yeah, I think it's going to ask you which configuration you want that change to apply to. And you can set all, or you can select the ones you want. Yep. Yeah, I think that's the beauty of configurations actually, to have and do all that. And what we see is most people is that when they build these models, they'll build configurations. If you're good at configurations, I would recommend it on here because then you can always go back and change things. But if you're not so good at configurations, save it and then save as copy and then build the next version of it. So multiple different ways or multiple ways to do it. Depends on what you're comfortable with.
Single quote, double quote, doesn't matter.
I'm doing double, but we'll try it on single quote and see if it works. I'm not sure, but
some characters are reserved.
Yeah, we can try real quick. Actually, we'll just let's just delete this and
Like also the questions, the people that are live streaming.
Yeah.
Hear the questions, so
Okay.
I think you should repeat the question.
Okay. So we're trying to figure out do we need to type in single or double quotes here to call it the variable. So let's just try singles. This is B. So this is just single quote. No, it doesn't. So you see it just says 200. So let's go back here and a double quote B, double quote. Yeah, let's not do it either one. Let's just delete it and try it again. I think it has to be double quotes. Actually equals, I'm sorry, single quote B. Yep, okay, so the syntax is incorrect. So it does have to be, I forgot the equal sign before, is what happened. So it has to be double quotes. So equals, you can go through and click this as well. You can go, and you can choose it this way. I think it's a little bit probably quicker just to hit equals double quote B, double quote, just like that. The main thing is you want to see this equation marker there. All right. So even though it may evaluate and give you the 200, if you don't see the equation, when you update it, it's not going to change. Right. So let's let's extrude this. I'm going to grab my extrude tool again. I have it on my S key there, so I don't have to go up to the feature manager to do that. And it's going to be 25. And there's the base of our part. If we look at the part, we do have fillets around the outside. All right. Years ago, it always seemed to be better to put fillets and chamfers at the end of your feature or the end of your feature tree because it didn't interfere with things. I still kind of hold on to that today because it makes it easier to offset and trim things like that. And in my experience with this model, it's easier to wait and do the fillets at the end. So the next thing I'm going to do is I'm going to build this vertical wall here. And you can see we have the shape here. It's basically all called out in this drawing view here. You can see the 80 millimeters with 15 millimeter offset, and then the 80 millimeters over here, and basically 15 millimeters wide. So you can see in this case, this 15 millimeters is called out three times. So again, that's where we're basically trying to give you as much information, if not more information than you need. So let's build that shape. I'm going to start on the bottom here. And I'll show you why, because it's the way that the drawing calls out the extrude. Okay. Actually, let's go back to the drawing. You can see that this has a height of 95 millimeters right here in this drawing view. All right. And that's calling it from the bottom. I can sketch on this surface and do 95 minus 25, but what happens if that 25 changes? Okay, if that gets thicker, it's going to grow, right? So it's best to kind of model things the way it's called out, so it doesn't change things. So, and I'll show you a different way to do it. You can sketch on that side, or I'm gonna do here. I'm gonna sketch on this face, and then we'll just start drawing that. And when we get to the extrude portion, I'll show you what the trick is. So I'm just gonna grab my line tool, and I'm gonna click here. I'm gonna drag vertical, and I'm gonna move away. I'm gonna come back, and it's gonna turn into an arc. Okay, so that's a quick little trick there. Let me just redo that again in case you didn't see it. With the line tool, when you come, I'm starting from the edge, and when I terminate it, if I move away, it's a line. If I come back, it turns into an arc. Okay, and I believe you can actually hit A, and that does it again. And it'll toggle the way the arc goes by hitting the A key. But if you just kind of drag back over it, it'll turn into an arc. It's a quick way to sketch an arc. Drop that there, and then come over to that edge. All right, and that's my basic shape. I'm going to window select that, and I'm going to hit offset. And this is going to be 15 millimeters. And over here, I'm going to go cap ends, and I'm going to use lines and click OK. And you see what it did? It just sketched those 1, 2, 3, 5 entities for me without me having to do it. Offset it. So if we undo that, okay, I just window selected, I hit offset, sketch offset. And then over here, if it's 15 millimeters, you hit cap ends, and then you make sure it's lines. If it's arcs, you see what it does on the preview? It gives you the arcs out here on the edge. But basically what it does, since I put lines, and because of where they terminate, they're fully defined at that point. Okay, so that's my sketch as a whole now. So basically I just need to kind of position this sketch. There's no variables in this. It's just, well, I'm sorry, there is one. There's a C dimension, and then there's 80 and 80. So grab my dimension tool. This is going to be 80. And this is going to be 80. Now we could add an equal relationship here between those two to make them the same, but for some reason, the person that drew this put 2 dimensions on there. All right. So if this just said 80 times 2, then I would put equals. I can tell you now, this 80 doesn't change between the two. It always remains 80. But if it's called out twice like that, theoretically, there's a reason why, right? In this case, I think we're just trying to give you more information, but we'll follow the dimensioning scheme he has there. And then the distance is basically just C to the outside, from the origin to the outside of each one. So if I click here and go out to this line, again, adding a variable is just simple as equal, double quote C, double quote. And the same thing over here. Okay, and it's fully defined. Now, going back to that extrude issue that we have, there's a couple things I can do. I can exit the sketch, move the sketch down to the bottom of the part, and now I can extrude it 95 millimeters and call it a day, right? But there is a really cool tool with extrudes, is that I can offset the from location of this sketch. So I can go offset. Actually, I can do it from a surface or plane, and I can click this bottom plane down there. And then if I type 95 here, that's basically going to offset it down to that surface and then extrude it up 95 millimeters. So it saves me from having to move that sketch to a different plane.
Was the arc radius not called out?
So he's running if the arc radius is not called out. It is called out in the drawing, but the way that it's actually it is not called out. But because we're giving it a width and go back into the sketch, we would be over defining it if we did, because we're giving it this dimension and this dimension here. We're giving it the length there and the length there, plus we're positioning it, so this arc can only be one length. So it's probably some weird arc or some radius amount, some weird radius amount. So it's, well, actually it's a 90 millimeter radius, okay? But this fully defines it, because if we get rid of this dimension, it's no longer fully defined, because it can change, right? We can change it like that. But because it's called out in both ways, it fully defines it. The arc can't change at that point. So it's nice when it can just fully define itself. So sometimes if you get into a position where you don't know why it's not fully defined, I always just grab a sketch and I'd move it to see why it's moving. So that's why that was there. Okay, so that gives us to this point. So now the most important tip I can give you about taking a certification exam is to save your part. Okay, from time to time, we've heard that in rare occasions that SolidWorks will crash. Okay. So it's always good to save your parts. All right. So I'm just going to quickly save this on the desktop, and part 1 is a great name for it. And that's it. Okay. I would suggest just saving at every step, because we get emails from people that says, I got all the way through like the 5th iteration of the part, but I forgot to save my part and the power went out, my computer crashed or something like that, or SolidWorks crashed. Unfortunately, he's got to start all the way back at the beginning and go all the way through. All right, so save often and save it. In fact, I actually have on my S key right here the save key. All right, just to reinforce that. Okay, so that gives us that vertical wall. The next thing I want to work on are these bosses. All right, these little these bosses that are sticking out there, and then we'll work on this cutout down there. So I'm going to sketch on this face. And if we look at the part, there's a couple things. They are on the edge or the midpoint of what that boss is right now, that vertical wall. Obviously, we're going to cut a piece of it away, but that's where it is. So that gives us the midpoint of that little part that's standing up, the perfect spot to sketch these. If we look from the top view, it actually sticks out 10 millimeters, right? So I can create a plane, offset it 10 millimeters, and then reference that midpoint, right? But why go the extra step of creating the plane? It's another additional feature. Maybe it takes us 10 seconds, but at the end, how valuable is 10 seconds, right? It builds up. So again, I like to point out the tools to kind of help you get through these things faster. So let's create those bosses. We're already in sketch mode on that face. I'm going to grab my circle tool and I'm going to sketch 2 circles at the midpoint of that part. And I'm just going to roughly sketch them. And these are called out on this boss. The outer diameter is X. So we'll dimension this and we'll give it the X variable. And then the inner diameter on this one is E. Okay, and if you're quick on the double enter or tapping enter twice, it'll accept it and close the dimension tool. I do notice that I have to move my mouse off the dialog. Otherwise, it just seems to get tied up there for some reason. So there's our sketch there. And then we're going to do an extrude. So we'll grab the extrude tool. And then again, I want to offset. This time I'm just going to use the offset, and it's going to be that 10 millimeters. And then I want to change the direction, and the length of this boss is actually called out of the variable as D. So over here in the feature manager for the boss extrude, in here we can actually type equals D, just like that. It'll evaluate the number and create it. All right, so now we've used that variable in 2 different places, in the dimension and then the extrude value. Let's go over here and we'll create the same one, or the similar part. This has different dimensions. Again, it's just a couple of circles on that midpoint, and then some dimensions. I like to dimension the outer one because that's going to be the bigger one first, so you don't end up with 2 lines on top of each other, and it happens a lot. Then you have to zoom in, and it just makes it a little bit more complicated. So the outer diameter on this one is Y, so equals Y. So see if I hit enter twice, sometimes it'll work, sometimes it doesn't. And then the smaller inner diameter is E. So that time it worked. Okay, and there's that part. Again, just like we did last time on the other boss, we'll extrude that. It's going to be 10 millimeters. And then we'll change the direction. And this is going to be, this is also, the length of this one is D equal as well. All right. We'll save that so we don't lose our work. So there's our bosses. We obviously we have these 2 parts in there. Now at this point, I've not figured out a better way to get rid of that other than to just sketch on here and cut through both those tubes. So if anyone has a better idea, I'm more than glad to entertain it. But it just seems to be the simple way.
Couldn't you just have 2 separate bodies and subtract one body from the other?
Yeah, that's true. Yeah.
Okay.
Mm-hmm.
You can convert entities and trim.
On here?
Yeah.
Instead of cutting through it, or
Yeah. So if you took that plane and you converted entities, all those lines become construction, and then you trim it.
okay.
So they disappear.
Yeah, I'm going to do something similar. I'm sketching on this face, so I'm going to grab this this inner edge here. I'm going to convert that entity right there, and then I'm going to do an extruded cut. I'm going to rotate around and just double click this face, and that's how I can find the quickest way to do it. So again, maybe you're better with the intersection tool. I would probably fumble around with it for a few minutes. So
That's probably where I failed.
But yeah, I look for the quickest way. I mean, there are these great tools that come about in the software that are handy, things like that. But maybe sometimes we get sucked into wanting to use them and forget about the easy way. But I don't claim that this is the easy way whatsoever, but I can basically do it in just a matter of a few clicks. You know, the one thing I do is I have my option to rotate the part to the feature, and that's kind of bugs me. But I mean, at that point, I've cut them away, and that's quick and dirty. I actually tried, you know, modeling these first and extruding this up, but it just seemed like to me this is the most straightforward way. Okay, so that gives us our two bosses. So let's go back and look at our part. The next thing we're going to do is this little boss right here. Okay, and there's a reason the reason I want to do this before I do that cutout there is because the cutout actually references that shape. So I'm going to use that shape to my advantage by putting it in line first.
So just really quickly back to bosses.
Yeah.
The way you could have reflected it about a plane, you could have created a plane down the diagonal and then just reflected it.
Like, yeah, they're different. That's the problem. Yeah, because I thought about that this morning actually. So he's asking, could we just mirror these two bosses? But if we look and see, the outer diameter is different. So this is 76,667, and this is 71. So, yep, it is. Yeah, yeah. So take advantage of mirroring patterning whenever you can, when it's an option there. But just be careful. I can almost guarantee the guy on my team that wrote this probably changed that so you couldn't mirror it or rotate it. All right. So that's the only reason why. It sucks people into thinking like, oh, I can just do that. But, you know, again, part of the exams are getting you to pay attention to a drawing as well. Right? We've seen throughout time multiple instances where somebody either made something, didn't look at the drawing on a dimension, you know, maybe didn't convert the units correctly, right? And sent up mirrors into space that didn't work, or probes that crashed into other planets, you know? So again, part of the exam is like, you know, also training people to pay attention to drawings and find those little things. So, but again, sometimes designers, when they draw stuff, their drawings are weird, you know, it's hard to follow. So when I was at the mold shop, when it depended on who was going to build a mold, the drawings I would create were tailored specifically for that person because they liked the drawings a certain way. So it's just one of the things, you know, when you don't work to a standard, which in itself can be some problems. But so let's make that boss now. Just going to sketch on this surface here. And again, I'm going to grab my corner rectangle tool and we'll drag it out here. And this is a pretty simple one. This is just a 60 by 60. So 60 there, and then 60 over here. And let me know if I'm going too fast or clicking too fast or anything like that. And then I'm going to extrude it. So again, we have to put a fillet on that corner, right? So right here, it calls out a 15 millimeter fillet on the edge. So I'm open for anybody's opinion on whether it should be at the sketch level or a feature level. Okay. In this case, the way it's dimensioned, I'm tempted to just put it at the sketch level because I'm not using like a center rectangle, which sometimes can cause some errors because you trim away that corner.
And the offset depends on it.
Yes, that is true. Yeah. So, and so in that case, I think it's easier or better to put it as a feature. So, but in this case, it works. The reason why, and I may get this wrong. I have to remember we've done it both ways. And so in the next iteration, this boss gets removed and that pocket extends out. So when you suppress that, that boss, the pocket explodes, obviously, right? Because part of the geometry is gone, the offset geometry. And when you go in to edit the sketch, because of the way the fillet was created, it's just like unrecoverable. And you end up having to wipe out the entire sketch and start from scratch. So I'm trying to remember the way I did it this morning at Starbucks. I think I did it, so I'm gonna do it as a feature, because I believe that's the way I did it this morning. This is basically 10 millimeters above that face. So this is just gonna be a simple 10 millimeter extrude, just like that. And then we'll add this fillet in. And I know I called it out. It's a 15 millimeter fillet. Yep, actually now I'm remembering this morning I did it because I remember selecting through. Everybody have that option to turn on selection through faces, select edges through faces. How many of you guys use 3D mouses? I know you have. Does anybody else have one? I'll tell you that the driver for those devices will tend to turn that feature off at random times. the selection through how I'm able to select that edge. Yeah, I think it's select lines through graphics or something like that. The drivers for those devices will turn that one off, and it'll turn off some other like dynamic highlight option in the software. It bugs me a lot that it does that. But it's kind of carried over through the drivers through years. I don't know why. So if you see it turned off and you're using one of those, you'll know why. In fact, I think at one point I actually had a macro that when that would happen, I would just click the button, it would turn them back on for me.
It's funny that it wasn't giving me that problem
Yeah,
earlier.
yeah.
And right when you started talking about it, it did.
Oh, maybe it's a magic thing or something. Yeah, it's frustrating. Yeah, because I love those devices. I have that same one that I carry. I usually travel with it. TSA usually always flags my bag for it because there's a heavy chunk of lead inside my bag. I'm sitting here like this with my hand over here, just like in this position, like by nature. So, all right. So we got that boss there. Let's go back and take a look at our drawing. We're setting ourselves up to create this little kind of this cutout in there, the pond, if you will, as I like to refer to it. It's basically just a 9mm offset from everything. And then it's got this 10mm fillet inside there for the corners. So on here, what I'm gonna do is I'm gonna click this face. This is gonna go pretty quick. It's just a few clicks to create this. I'm gonna click this face. I'm gonna sketch on it. And then without deselecting it with that, in other words, with that face still being highlighted, I'm just gonna grab the offset tool. And then that's where I'm going to work from. I'm going to change it to 9 and I'm going to reverse it. And there's my sketch geometry. Okay, really, really simple. Just a couple of clicks.
How do you add this to the S click key?
Just like any other toolbar. So when you're in it, you just right click and you customize. Now there is a weird little thing about this. I think it's still on there. So if we just grab one of these random tools and we put it on here, SolidWorks loves to just resize that toolbar for you. Okay, it's frustrating. I don't know why it does it. I like to have mine extended out like that, but every time you add one to it, it resizes it. Okay, I think by default it looks like this. I think is how it looks, but I just like mine extended out. And again, this is the sketch level. It's a different toolbar at the part level, different at the assembly, and at the drawing level. All right. So once you get those set, are you guys familiar with the export settings wizard? That's in there. So once you get your toolbar set, not to get too far off topic here, under the SolidWorks folder inside the thing, I think it's SolidWorks Tools or SolidWorks Tools 2018. There's a thing called Copy Settings Wizard. So when you get your settings just the right way you want it, you can use that tool to export your settings. It's basically a registry file. I think it's SLD REG actually. And I learned recently, if you take out the SLD and just leave it REG and you run it, it'll set all the things without having the user interface come up. But just export your settings. And then you can carry over. Like if it's handy when you go from one computer to another, or if you have multiple computers, you can carry those settings over.
Real quick, real quick. Hey guys, real quick, if you have comments that pertain to this or questions, just speak really loud because people can hear in the background, but they say that if we speak a little bit louder, they'll hear us.
And I'll do a better job of trying to question. Yep.
I'm getting all kinds of comments right now too.
Yeah. So basically, this is just a copy settings wizard. He originally asked how to customize the S toolbar, but this is it. So you have saved settings, and then when you save them, you just port it to, or you just move it over to the other computer, and then you just restore settings, or you can double click on the file, and it'll set it all. There's multiple things that it can set. Let's say I have an active session, so it's going to tell me that it won't grab everything, but basically these are the things that you can do. So it's toolbar, system options, everything. So usually every time when I upgrade from major versions, I'll export the settings, and that'll be my newest kind of file.
And then
So
you just import those every time?
yeah,
Okay.
yep. So like I just bought a new little Surface laptop because to not have to carry around this giant PC anymore. That's what I'll do is I'll just grab this file and it'll make it. I'll feel right at home once I log into it. Right. So it's very handy to have. Very tool. I think I have settings files that go back to probably 2001 at this point. So, all right. So we've got our sketch geometry on there. We need to add the 10mm fillets. So I'm going to, again, hitting the S key, I'm going to grab my fillet tool. Now on here, I want to select these in a purposeful way, right? The very last point that I select for a fillet is going to be where it adds the dimension. So thinking ahead, I know that I'm going to get rid of some of this stuff because the boss is going to disappear. All right, because what I've done, and I encourage you guys to do it, is when you start the exam, click through all the questions really quickly just to see what the model is going to look like. All right, that's one of the advantages. Like you guys all design parts, right? Somebody comes with an idea, they say, hey, here's my sketch, can you model this? Okay, you don't know what the end product's going to look like. In fact, most of the time, it probably looks way different from when it initially starts. So the advantages here is you get to see what it's going to look like at the very end. So I know it's going to be there. So when I do this, I want to make sure that the last one I click is going to remain. So I'm just going to start clicking these corners here, and then I'm going to right click, and it's going to add that 10 millimeter fillet or dimension to the very last one I have. Now, if I had added it to this one here, and my next step, I get rid of that fillet, what's going to happen to all the rest of those fillets? They're going to turn blue. And as long as you don't move them, you'll be okay. But if you accidentally stretch one, that's going to be it, and it's going to throw everything off. All right. So again, the very last one you select is going to be the one that gets dimension. And I just I worked on that this morning because it caught me last time, and so I was able to do that. So at this point, we have our geometry. It's fully defined. We just need to determine what the extrude is going to be. And we can see down here is this calls out 5 millimeter thickness at the bottom. So again, there's a couple of different ways to do this. We know that this thickness is 25. So if I cut that down 20, it leaves us with 5 millimeters at the bottom, right? But if the model changes and that gets changed to 30, now how thick is it going to be? 10 millimeters. So it's going to be wrong. Okay. So there's, again, a few different ways to do this. You can offset that sketch a few different ways. Because I've clicked through and I know that it doesn't change, I'm just going to simply cut it down 20 millimeters, okay? Because in this case, I know it'll save me a little bit of time. We've done some really complicated like extrudes where it offsets from a surface, then offsets the other way and cuts through it. But in this case, just type in 20. It's simple that way. So again, as long as you know if that's not going to be affected, then you can do that. So extruded cut, and I'm just going to cut that down 20 millimeters, and that's it. It's done, okay? All right, just a couple more things to do on this part. So we need to put this hole wizard feature, and then we need to add these 2 millimeter 45 degree chamfers on these edges. Okay, and I believe that's it. Okay, so let's go back here. Let's add that hole wizard feature. So hole wizard is kind of fun sometimes. It used to be a very terrible tool to use back in the day because it was managed by like I think it was like an access database or something like that. And then they've since switched it so it performs a little bit better. So I click on this surface. I pre-select it on purpose so that when I launch the tool and I position it, I'm not in a 3D sketch. All right. I don't know too many people other than people doing weldments that use 3D sketches, but it can like put things in weird spots and at weird angles if you select things kind of strange. So a trick on the for hole wizard, if you pre-select that and then launch the hole wizard tool, which actually I have right here, it's going to put that location sketch on that face. Right. So just kind of a handy way to do it. The variables are in our thing. What it calls out is this is basically we give you everything starting from the top to the bottom. So this is an ANSI metric counterbore. So counterbore is selected. Obviously the standard I need to change to ANSI. So it's ANSI metric. And then it's a hex bolt. And it is a ANSI B18 2.3.5. So you see it's there. The size is M8. And then the fit is close. And again, this is all called out in the question itself. Like literally, you just go down and we call everything out. All right. And basically, it's just so we don't change the default values of the hole wizard, by the way. Right. We use the standard, but we put it in there so you can confirm that is correct. I mean, it would kind of be like a cheesy way to make people fail, right? By changing like the fit or something like that, changing the number. So we don't do that. So close fit. And then you can actually check the custom sizing. So, the through hole diameter. So on mine, I'm referencing a toolbox that I used to use at the mold shop. All right. So we use different type bolts so we had our own custom sizing. So mine are always wrong on here because we changed it. So I've carried that toolbox with me for years, and that's why it is. So the through hole diameter is going to be 15. And let's see, the counterbore diameter is 30. And then the counterbore depth is 10. And then it's going to be, the end condition is through all. So there's my settings in there. Again, just double check those and make sure that you haven't changed things. The positioning you can see, I'm just going to grab it like this. I'm just going to drop it for now and right click. And so now when I need to go back and I need to position it. So what I could have done is I could have sketched on that face first, but I can quickly go back into the positioning sketch, edit it. And what I'm going to do is I'm just going to draw a construction line from this corner to this corner. And then when I grab this dot and I drop it on there, there's the midpoint and it's positioned, right? That's quickly how to do it on there to position that. All right, two more things. The fillets on the corners and the chamfers. So the fillets are called out as 10 millimeters. So we'll grab the fillet tool and it's set to 10 and we'll grab these edges. Again, I can select through, as long as I don't have my mouse on here, I can, the 3D mouse, I can select that edge because it hasn't turned it off. There's that. And then our chamfers on here. And let's see what the chamfer calls out. 2 by 45. So my chamfer tool here, type in 2, and then I'm just going to grab these edges. This is where a 3D mouse comes in handy because you can quickly rotate around. All right? And so that's it. Can anybody find one thing that we've done wrong? There's like one glaring major thing that we forgot to do. And it's really going to throw off the answer. Yes, add material. All right. So whatever my default material is, I'm sure it weighs something right now, because my default material is not set to air, right? So it does weigh something. Yeah, it's there. In fact, it's close to what we want. So we need to set the default material. Okay. And that is just what do you call it? Alloy steel. So right click on material, and you can see it says not specified. If I was really smart, what I would do is I would add alloy steel to my favorite materials and I could quickly select it. So if you find yourself using a lot of materials, even plastics, whatever it is you guys are using, you can quickly set them in there and it's just a really quick thing. Simple click. So edit material. Again, alloy steel is just listed in here like that. Apply and close. All right. And there's that familiar color, right, that you guys saw in the PowerPoint. So at this point, okay, we should be done. All right, so now is when we're going to look and see. So let's measure this thing and see what it is. So let me change my options here. I'm going to go down to 2 places so we're not dealing with 4 places. And we're at 14207.34. Okay, so everybody see the answer right there? Number D, or letter D, right? Okay, so in this case, we got it right. I think that's the first time we've got it right in like at least the last 3 times I've done this presentation. So we forgot something. So yeah, it's encouraging that we got it there. All right. So that's basically it. Again, at this point, you see a number that's exactly matches what you have. So now you feel good. All right. You know you're there. But from here on out, it's going to ask you just to input the value. All right. So those changes don't really, you're not as you know, confident in them, if you will. Okay. Now let's look at the next step of this. So now what happens is, it's going to tell you, okay, use the part you have, change it to these dimensions. Okay. Now I think what I actually do, if I remember, I think I skipped this change because it actually asks us to change it twice. So let's see. Okay. Just want to make sure that I'm at the right one. Okay, there's that one, that one.
And by the way, when you're taking the test, actually, you can do a save as copy every time you're going to do a new variation of this.
Yeah. Yep, you can. Yeah, it's probably preferable to do that. Save as copy and open. Okay. So what that does, what he asks you, like, basically what he asks is like the best way to move forward and save it for save as copy. We know this one is good. So we can go up here, we can go save as, and we can go right here, save as copy and open. Okay. And then you need to change the name, right? So we can go part 2 or we can go step 2, whatever you want to put it. So if we go 2, what it's going to do is it's going to, yeah, let's replace it because that's the one I did this morning. So now what happens is we have the first iteration of the part and now we're working on the second step. So if something goes wrong, we have somewhere to reference back to. If you're good with configurations, make a configuration. You know, with me in configurations, I've always kind of like, I don't know, I've never enjoyed them, but so I'm, you know, I use that method instead. So let's see. The next step here is we're going to go to, there's that one and that one. This is just easier for me to manage my numbers here. Try to remember what the next one is. 209. Okay. All right. So yeah, I need to skip that one. Okay. So we're going to change some variables here. And as you can see, everything changes here. And what we do is we actually change, on the drawing itself, we don't, I thought I had it on here. Let's go through here. You can see here, what we do is see these little boxes around these dimensions. Those call out what's changed, right? So you can look for those boxes. Okay, so on this one, this is the next step ahead where we actually modify the geometry. But in the exam, what it's going to do is it's going to give you the drawing and it's going to say, hey, these dimensions changed, or it's going to tell you what changed in here. Okay, so in this case here, it just is basically just updating the variables. So let's plug in these variables and see what our answer is. So the quickest way to do it, right click equations, manage equations, and then we're just going to change some values in here. So this is going to be 209. This is going to be 218. See if I can tab over if it's easier. 169. Let's see, D. I'm just double checking because last time I did this, I got one of these wrong. We couldn't figure out why, and I had typed it in wrong. That's what I did. So D is going to be 125. E is 41. That's not changing. X is still A divided by 3, and Y is still B divided by 3 plus 10. So we're okay. So we can click this right here, and this will rebuild the part, or we can just click OK. Okay, and it just automatically updates. I always like to force a rebuild. So I hit Control Q, which basically rebuilds all the features in the tree. Okay, be careful when you have like a huge model, because hitting Control key, we like to call it the afternoon break feature, where it can take like 20 minutes to rebuild and you get to go have a break. So if you need a coffee break, that's a quick way to do it. So Control Q, I know that it rebuilds everything, all right? There's a few different methods of that'll rebuild certain things. So at this point here, we should be able to evaluate this again, and it should be, so it's 15146. Let's go back here. So 15100.47. All right. So this one I was pretty confident we were going to get correctly because it was right the first time and we just had to make some changes. So we're good. We're on a good path there. Now is when the geometry changes. Okay. This is what happens after you do a few iterations. Then you say, okay, now let's change the geometry. Now this is going to depend on how you modeled things in the first place. Again, when we were talking about how we modeled the boss, where we dimensioned that fillet and how we offset those things is really going to lend us a lot of ease of use at this point, okay? Because we did things in certain ways, we won't see so much stuff blow up on us, if you will, all right? So what we see here is there's a couple of big changes. One, we get rid of that boss and extend this corner out into here. We cut this part out over here, and then we add this, this cutout here are the major things. And then in the descriptions here, we can quickly see that the material is still remain the same. There's still the variables here, but there is this note. And see over here, it's note, the equation for Y has changed from the initial part. Again, we could just change this without saying something to you, but he actually calls it out in the exam to make sure those things are there. All right. What he wants you to do is basically he wants to make sure you're actually using an equation instead of trying to do the math manually. Okay. So that's why it's called out there. So let's go through and let's remove this boss, get this, remove that counter bore, get this pocket filled in or cut out, and then cut this pocket out, and then we'll come back and we'll do that cutout on the boss itself. So, all right, so we're done with that. I'm just going to quickly, I'm going to take this, I'm going to suppress these two. Let's see here. That one. And actually what I can do is by just suppressing that one, it'll suppress the child features. But see, it also suppress that cutout, right? Because there's stuff dependent on it. So you got to be careful with that. So, and see what happens here. This is a bug or something in this part where now that I've done that, no matter what, that sketch is blown up. So I'm going to close this because I want to show you how to do it. Let's open this part again. And because I had saved it, it's there, right? I can quickly go back to it. Okay, so let's just, let's suppress this. because we don't need that. We don't need the fillet. That's why it's going to do that. Okay, so let's go. Let's try to go. Let's start going in here. Let's see. Let's go in here and try to think of this. I think I want to go in here and work on this sketch of this part first. All right, we know this is going to disappear. So what I'm going to do is I'm going to just delete. I'm going to delete some things. I'm going to grab these because I know those are all disappearing, and I'm going to delete them. All right, now this one, the relation. This is interesting that I did this. The relation between this again is kind of weird. So it's the way that I selected. I'm going to quickly add these back. So what I'm doing is I'm control selecting those arcs, and I'm going to make them equal. Okay, so now we're back to fully defined. All right, we know that there's still a 10 millimeter fillet in that corner. So I want to add that back in. Now I can drag those lines, connect them, and add a fillet, right? Or I could draw lines, whatever I want to do. But here's a quick way to fix this. Okay, using the sketch fillet and set to 10 millimeters, just click these two lines, and it does it. So remember back in the AutoCAD days, you could do that with you could quickly trim things with the fillet in it. So I think it goes back to that. Some of the things in SolidWorks are based back to AutoCAD, okay, and how the functionality worked back in the day. So that's how that worked. The nice thing about this is now we've removed any references to that boss. So now we should be able to just take this boss and its fillet and suppress it without affecting that cutout. Okay, so we removed any references to that thing, and now it's there. Okay, so that's good. So we've got that in there. Let me just double check. 9 millimeter offset, 5 by 10 around. Let's cut out this back portion. Okay, now I'm going to sketch on this face. Okay, we're sketch on there. Remember, we want to make this shape here, this cutout back here. Okay, now earlier what we were able to do was take advantage of the offset tool, right, of the geometry, the face that we were selected on. Unfortunately, what's going to happen is that it'll give us all this stuff. All right. So I just want to select the things I'm gonna offset. So what I'm going to do is I have to do 2 offsets here, and I'll tell you why. Offsets have to be, the geometry has to be connected for it to offset. So if I select this edge right now, it won't offset because they're not connected. All right. I don't know why. I don't understand why. I kind of wish that it would. And I almost think that it should, but I don't know if that's just a limitation of the software or how the tool works. But anyways, this is going to be a 9 millimeter offset. So we're just going to do a couple of quick offsets here. So 9 millimeters, and I'm going to reverse it. And there's that piece there. Actually, hold on a second. Let me undo that because it's going to give me the wrong fillet in the corner. Let's see if it'll do this. Yeah, see, right there, it won't do it because they're not connected, right? If I unselect this, it'll do it. So I'm just going to offset a couple things there. So I'll offset that. And now that since I have 9 millimeters typed in, it's just going to give it to me each time. Click there, and then we'll offset this 9 millimeters. Reverse it. Okay. I'll need to add a couple lines because basically what I do, if I try to drag this, it's an extension of the arc. That doesn't do me any good. All right, so we just need to draw a couple tangent lines. The nice thing about that, it's basically horizontal, so that makes it tangent to begin with, out this way. All right, and then those are 10 millimeter fillets in those corners. So again, I'm going to do this. I'm going to grab my fillet tool, make sure it's set to 10 millimeters, and just start selecting these items. Now, depending on where you click over here, that was not it. Sometimes it'll give you the arc going the other way. All right, so you can see the preview. That's why it's the preview is handy here. Okay, and there's my profile. So quickly built that profile there. It looks like I have some. Oh, I thought that was geometry left over there. What version are you guys using, by the way? 2018. Okay, good. Usually at large companies, they drift a couple years behind for some reason. Oh, 16.
Yeah, we got 16, 18.
Okay. So do you have the colored icons back yet? Or what service pack are you using? Probably 5?
I always switch it back to the old. Small icon mode.
Oh, okay. Yeah. These. So do you guys remember the colored icons versus the gray icons? It was the controversy of the century for us. It was incredible. No matter what we do, that was the thing that really kind of, it was not popular whatsoever. So we fixed it, but it was, to give you guys some background and not to get too far off track again, we updated, there's something like 2,200 icons that were recreated so we could take advantage of high DPI displays is what it was. So I think now they can scale up to a 10K resolution screen. So in a couple more years, we'll probably have to do it again because there'll be 20K screens out right at that time. So that's what it is. So yeah, you guys should have it. If as long as your Service Pack 4 beyond in 2016, it's colored icons. But like as you said, you went back to classic mode. So again, the reason I brought that up is because you see those two dots right there. It almost looks like it's like a sketch entity there, huh? And that'll screw things up. Visually, I should have known it wasn't because I see the sketch contour in here, that blue thing. That's telling me that there's not, that it's a closed contour and it can do something with. So sketch contours are pretty cool. That came out of like a CATIA product actually. So one of the cool things is we're starting to like share technology between the products. And this is one of those things that it was just a visual kind of pleaser that we put in there. So this actually gets cut down to the same level as the other part, as this other pocket. So the quickest way to match this here is do an extruded cut and just double click on that face. And that's it. I don't have to type any numbers in, and it matches it to it. Okay, yeah, double clicking the faces is up to yeah, because it keeps you from having to go over into the feature manager and doing it. You know, again, trying to stay in this area. You'll see I do go up here and there here time to time, but for the most part, I stay in that area. So let's go back and see. We need to make this cutout here, and then I think that was about it. So he changes some of those things. I don't think he changes much. Yes, right there. So it's 2 by 30. Okay. And I think that's about it. And then we'll have to update the variables. Okay, so let's sketch on here. Sorry, I'm thinking about something else while I'm doing this. Okay, so we're sketch on here. I want to cut that out. Basically, it's a 10 millimeter offset from, let's see how he calls it out here. Yep, so 10 millimeters from here. So this, I'm going to offset that 10 millimeters. So reverse that. This is where trimming, you have to be really good at trimming, or trimming comes in handy. So usually I try to, sometimes I have to rotate around to kind of see where that dark line is. I can't see. That's why I keep up here. I keep this normal 2 button on my, I forget what it's called, the view toolbar, or I can't remember what this toolbar is called, but I keep that one there so I can kind of move things around. And then I'm just going to grab these 2 lines, control select them. I like to reuse geometry as much as I can instead of sketching stuff. That way I know I'm not missing like a corner or a vertex or something. And then I can drag these up. And then so that gives me that. The last thing I need to do is I just need to grab this outside and convert that one. And so now I can start to trim things around. This is where I always get, you know, those puzzles where things turn inside out when you look at them. This sketch always does that to me as I'm trimming. So I know I need to cut these out from, let's not sketch. These 2 look too much alike, or they're too close to each other. Cut those. I believe that, and these. Did I cut something too much? I think I need to trim them more. There we go. Right, that's still there. Yep, there it is. Okay, I just wanted to make sure it's not giving me a contour, which is kind of, I just, you know, it makes me look, I'm lying to you, right? That I don't have a contour there for some reason. I don't know, but it's giving me a preview. Anyway, so again, let's go back and we'll look at the drawing, see how this has to be created. It is, this arrow is right in the way, but it's basically 30 millimeters from this face, and then it's 30 millimeters deep. So we'll grab the extruded cut tool. So I'm here, it's just gonna be an offset. I'm still kind of bewildered why it's not giving me a contour. So offset, change the direction up here. Sorry, get some buzzing. And then this is gonna be 30. Okay, and there's my cut. Yep.
Earlier, how did you get the blue highlight or everything? What was
The contour?
yeah.
I don't know why it wasn't showing on that sketch. That's why you saw me kind of like clicking some things, trying to check.
Yeah.
See, now it's giving it to me. So,
What was the icon you clicked on to get that?
I just cut extrude that we're doing.
Oh, no, like earlier, when you were able to highlight the entire circle all the way through, and then that's
Oh, convert entities. Do you know, are you doing convert entities tool?
but then it would, like, you just selected that face and that was it, right?
Yeah.
Oh,
Yeah. Yeah. So when I go into a sketch, you'll see me, I'll tend to click things in certain ways if I know I'm going to convert entities. Again, I'm a big proponent of reusing geometry. And to me, that's what parametric modeling is about, is reusing and linking things so they all kind of work together. So probably there, if it comes up again, point it out. Stop me at that point. I think we might be talking about two different things, and I want to answer your question. So we need to go back in and change the chamfer. That's 2x30. So I'll ask you guys, this kind of came up in a meeting. Does it matter which way the 30 is for how much the part will weigh at the end? It's one of those questions that makes you kind of think, right? Because it could cut one way or another, right? Because it's basically 60 versus 30 at that point. Maybe somebody online
I
can.
don't think it would affect the weight.
It shouldn't, yeah. So, but we had a really fun time. We spent like half an hour kind of debating it back and forth. But so 2x30. So I'm going to leave it at that, and we'll accept it. Okay. I'm not sure why he changed that, and kind of makes me want to ask him why he put that in there. Because usually there's a reason why he kind of does things. But I don't know. I'll have to get him on the phone and see at some point. All right. So the last thing we need to do is go back and change the variables here. And I'm going to just save this. And again, I know we're on part like 3 or 4, but for this occasion, I'm just going to overwrite what I have. Again, manage equations. This is going to be 221. B is going to be 211. C is 165. And what I'm doing here is I'm just hitting enter, and then I'm hitting tab twice or 3 times to get until I get to the next one. It's quicker. To me, it's easier than trying to select. And I think what got me in trouble that one time is I misclicked in that wrong box. So D is 121. E is 37. Okay, now for X, X still remains the same as, A divided by 3. But B changed, remember? So this is B divided by 3 plus 15. So in this sense, I can just click in there and change this to 15. That's probably the easiest way. And then click OK. And it'll rebuild the part. I can force a rebuild again. And that should be it. I got a feeling we missed something, but let's see what we have here. So we're at, for a mass, 13,206.39. So 13,206.40, right? Okay, it's working good today, so I'm kind of happy in that respect. And that's basically it. Okay, how are we doing on time, by the way?
We've got 45 more minutes.
Wow, okay. So we can get into some expert stuff. I like in there, but I just kind of want to talk to this a little bit more. On the end of there. So for everybody online, or if you guys want to write that down, again, if you guys have questions about it, if you take an exam and you don't know why you failed or something went wrong, feel free to write to us and say, hey, I took this exam and something happened, right? And we won't tell you exactly what you did wrong, but we can give you some hints, okay? I will say, don't write in and say, I know I got this right, your exam is wrong. Okay, because depending on the mood of the person that answers, he'll tell you, well, this question has actually been answered by 5th graders 100 times correctly, even though you got it wrong. So he'll, so it's just again, it's when you approach somebody the right way, right?
So real quick, Mike.
Yeah.
So the one that you just did, I know for a fact that I did this with the associate's test.
Yes.
And then when I went for the professional test, it was actually a little bit more complicated of a part, where it had the 2 extrudes, the 2 tubes.
Yeah.
And it had the flange that toggled down, it was tangent. That's where I had some problems.
Yeah, and again, if you have a question on a part, send us the model.
Okay.
If you have the model, and says, hey, can you take a look at this and see where I went wrong? Give me some information. The guys always love digging into that stuff to see where, where something was wrong and then giving you some suggestions. Again, the way that I modeled this and the way my tree looks today, I guarantee you doesn't look like the way I did it last time. But again, we all kind of learn as we go, and we can give you some pointers in there.
Okay, and real quick, everybody, I'm going to share Mike's contact information at the conclusion of this, and also the code to take the test. So, because I've been getting all kinds of people asking about the code.
Yeah.
Chimed in on the screen.
Yeah. So yeah, as Monty said, he'll share my contact information. Feel free to email me directly if you don't want to get the guys. I try to reply when I can. I'm usually really good about it. I was in Africa last week and I was trying to reply on the go as much as I could. So I'm always, I try to, to keep them. I don't like to be one of those people that when you see their phone, they have 453 mail, things in their inbox. So I try to keep it to 0 as much as I can. So, but yeah. And again, we love getting the feedback on these. This is a new version of the test that we debuted at SolidWorks World when you were there. So by now we're about 4 months into the exam. The data and the questions and all the answers are 99.9% good. Okay, we've fixed all the little errors or typos here and there. So if you miss something wrong, chances are you just missed something, but we'll help you figure that out.
So you're telling me that if I take the professional exam, this is where I'll be modeling right now?
Not this exact part. No, this is the sample part, but a variation of this. Okay. I want to show you guys something while we're still on the topic of CSWP. Let me just go to the exam really quick. Oh, I'm sorry, you had a question.
Yeah, how long is the test? And like this, the model that they would try to make a change or whatever.
Yep. So he's asking how long the exam is. Okay. It used to be, so it's a total of 3 hours and 45 or 50 minutes. Okay. But what we've done is we've broken it down into 3 different segments because we realized that you guys don't have 3 hours and, well, it says 3 hours and 20 minutes, that you guys just don't have that amount of time during the day. Okay. We're all running to meetings or doing stuff here and there. So what we've done is we've broken it down into 3 segments. One that's 70 minutes, one that's 50 minutes, and one that's 80 minutes. So you need to at least commit 80 minutes at a time for the longest one.
And then this you do like your work or home or whatever.
You can, so yeah, so he's asking where you can do it. You need an internet connection and access to at least SolidWorks. What version does he say? Probably 2015 or later. So we usually try to keep at least the current version plus the 3 previous versions. We know not everybody likes to upgrade right away. So that's it. You can have student edition or you can have your work edition, whatever you want. You just need access to the internet and SolidWorks to do it.
What about the portal? Do you have to have access to the portal?
Oh, no, only if you're going to redeem that code or if you need the subscription. But at this point, what I would say is if you guys want to take exams, anything up to but excluding CSWE, contact Monty or shoot me an email and I'll set you guys up with the codes with whatever you need. All right. We don't make a ton of money off these exams, but we want them to mean something. That's the most important thing to us. So if somebody comes to me asking to take an exam, I'm more than glad to help them out. All right. So again, it's broken down into 3 segments. My recommendation to you is to start with segment 3. For some reason, the order of complexity ended up being the order these are in. So segment 1 is the hardest, segment 2 is the next, or is the next easiest, and segment 3 is the easiest of all 3. So take segment 3, you get you comfortable with the tester software, you feel confident, it's just some simple assembly stuff, then do 2 and then do 1. What I've showed you guys today is heavily based on segment 1. Okay, so we've only touched like the surface of what you have to do in the exam. But it seems to be the segment that most people struggle with. Okay. This exam, if you want to, it's solidworks.com/CSWP, takes you to the site, and then you click on CSWP. Right here is a sample CSWP exam. That's going to download that PDF file that I'm working to here off my cheat sheet that I have sitting in front of me. And you actually, again, as I mentioned earlier, you take it online. So you actually create an account in our tester software. You take the exam, and it gives you the experience there. The other recommendation I have is, do you guys have dual monitors? You have a second monitor? That's the best way to take it. Okay. You can, if you only have your laptop, you can tile it with SolidWorks and the tester client next to it. But the more space you have, the easier it is.
If you take it at SolidWorks World,
You get one
you're
monitor.
looking at half of the screen with
Mhm.
SolidWorks, the other half you're looking at the instructions.
Yep. And you're in a room full of 30 people that are getting frustrated and slamming their keyboards and walking out crying. Sometimes we've seen so people take it really seriously. Are there any other questions about CSWP on there from the people watching online?
No, the last comment was talk louder, but I think that was for me.
Okay. So we have about 40 minutes or so. Somebody recommended, could I go through some of the expert stuff? All right. So what I'm going to do is any kind of, I'm not a sales guy, but any kind of demo person will tell you it's never good to try and just do something on the fly. All right. So this, even, I've done it a few times. I'm pretty good at it, but I don't mind. We'll open up I have some expert models. I may struggle with remembering how I did it, but we could probably just go back through and rebuild or roll back and see how they're done. Okay. So I'll show you a couple of those. We don't tend to shed too much light on the CSWP exam. We're talking about the expert level exam because we want it to be kind of a mystery and to have people go into it, just saying, okay, what am I going to see? And then being able to do those things. All right. There's no sample exam for the CSWE. For one thing, there's no training on my SolidWorks, any of that stuff. All right. So we list some on the website itself. I closed my browser. On the website, we list some topics that you may encounter. And that's about it, but it's, the exam itself is basically what I call like a series of workarounds, if you will. All right. They're data or problem sets that don't have a feature to solve, or they don't have a feature like, okay, how do I do this? Okay. There's not a feature. You have to use a variety of ones. So, let me see if I can go back in and dig up. It's been a while since I've been in here, so I'm not even sure what's in here, or if did I keep it on here? Expert exam. So I keep it in 2 different places. Let's see. So, all right, this is one that is still on there. It's got to update because this is probably a few versions old. So I'm going to save it so we get some performance out of it. So what this is if I remember correctly, you're given this assembly without the spring, and you have to model the spring in there. Okay. And then what we do is there's a distance mate here that we have you change. And then we ask you for the center of gravity on this. So right now it's, that's a weird dimension. Distance, there it is. So this one here, there it is. So it's 100. So as I type this in, pay attention to the spring on there. So let's go to 50. When I hit enter, you see the spring automatically updates. Okay. So now, without looking at we can't really see. Well, let me collapse this. How many is this? First of all, let me see if it is. So how many people think this is probably an obvious question. How many people think I used a helix to create that spring? When you think of a spring in SolidWorks, you probably want to use the helix tool, right? But that's not how it's created. It's actually created using a sweep. And that's what allows us to have it dynamically update like that. Yeah, because what happens he says to the different services, what happens is that it's the mating inside here. If I can find the mates, or it's actually the way it's sketched. Yeah, it's so see these arrows. How many guys how many people design in context in terms of an assembly? So what I mean in context, if you have a block with a hole in it, you want a pin to go in there, you model that pin in the assembly using that geometry. Okay, so when you look at this, this one's a bad example, but that's how I used to do all of my mold designs. They were all in context. So when you look at the mate folder, it just said in context over and over and over and over and over again. Okay, the nice thing about that is that when you change the size of something in the assembly, it was master sketch or master model method, I think they called it, is everything would update with it. So let's go in here and look at this suite, and let's look at the individual sketches. So again, this part is created inside the assembly. So I don't create the spring and then drag and drop it into the assembly. It's created inside here. So its spring has a couple relations. One, it's tangent to this edge. Okay, and then I think we give you this call out here in the thing, and then we tell it how many revolutions it should have. So that's one of the tricks there. And then the other sketch here is basically, as you can see, the diameter of the spring is 3 millimeters. So it's 3 millimeters from the edge. So what happens is that sweep, we'll look at the feature now. Again, I'm kind of clicking through these quickly because I don't want to start too much. And but if we look at this feature here on the sweep, it's a different way of doing things. So get rid of this. It's actually, we use a twist along a path. So that's the path right there. And then we put the number of turns in there. So we tell you the number of turns. So it's a different way. It's the best way to make a dynamic spring. And let's see I'll see if I can do this. If I suppress this, let's see if it works. Okay, that should allow me to move this block now. All right. Yeah, see, it's only gonna update once I hit Control Q. But see that? It just keeps stretching it. Okay, and it's because it had that tangent relationship up here, and then the path is always going to be 3 millimeters or the diameter away from that block. Okay, so what we do is we give you the block and the 3 pins, and we tell you make this spring. Okay, and obviously the path that everyone's going to take is they're going to model a helix with a spring, stick it in there, and they're going to get these numbers. The problem is when you use a helix, it doesn't quite end the way. If you look down at the top view of this part, the spring doesn't end like that. It actually cuts off perpendicular to the spring. So that sets off it sets the center of gravity off just enough that the answer is incorrect. All right, so that's one of the fun ones there.
One of the comments was, that is badass.
There's a way, if you're good at motion, you can actually animate. So, okay, and if you want to find out, if you want to review this, okay, I'll plug one of your guys' products, go onto YouTube and look for dynamic spring in SolidWorks. And that's where we got this from. That's where I got it from. So, and you can actually animate it to where it looks like the spring is actually compressing and then returning to its normal state. So, yep.
Can you recommend a list of review resources that one can go through that basically guarantee?
For CSWE, no. Because we purposefully, I have a really good relationship with the copyright team at YouTube. And so I probably take down about 30 videos a month of people but what they're doing is, okay, but there's not the ones that are like showing you like tips and tricks. There are ones that people are recording themselves taking an exam. Yeah, so those ones, yeah. So let me be clear on that. It's just the ones where they're like, okay, here's how to take the exam and how to model it, and then here's like a mega upload link to the files themselves. So those are the ones we take down. Like if somebody had this exact model, we would take it down. But if it was some other kind of like variable on it, a variation of it, we actually try to promote those things. So you can go on there, you can search for CSWP Prep, CSWP Prep in there, and you'll find some pretty good videos. But just like anything online, like websites, YouTube, just the internet in general, you got to dig through the bad stuff to get to the good stuff sometimes. You know, but there's some good videos, and we try to partner with some of them, like some creators. We'll partner with them and give them some exam codes to give away to help promote their channel and stuff. And when we do find the people who have recorded that stuff, usually they don't understand they weren't supposed to do it. So the first thing we offer is, hey, if you take the video down, we'll give you some credits. You know, we'll work with you to create a video and then put that up. You know, because we love that the information is out there and that people are sharing it. But we don't want it to just people give it away. So, but that's about the only place you're going to find, because we don't have a lot of stuff. We don't have anything on my SolidWorks for CSWE. You know, again, it's just kind of thing. But that's why there's only about 4,000 total CSWEs in the world. And probably only 1,200 of those are customers. The rest of them are VAR employees, because they get it for free and they get paid to take exams, right?
Better already answered this, but how often can you take the test?
All right, so he asked how often you can take the exams. So when you, in the instance, if you fail an exam, they vary. Okay, for most of them, you have to wait 2 weeks or 30 days. Right. And that's just because we don't want people, you fail it, take it the next day to pass it. With the biggest exception is with CSWE. If you fail it, you got to wait 6 months. All right. So, and I will guarantee you in 6 months, you've forgotten everything that was in there. And that was the main thing. The data sets we have available for CSWE are very limited because sometimes it's challenging to come up with those things. So that's why. Also, that we don't give that exam away very often, okay? So, again, we want people to really want it. But if somebody fails it and they write in, we'll usually work with them on covering the costs of taking it again. So, like if somebody fails it, a lot of times what I'll say is, look, if you want to take it again, you can wait 90 days and then you can pay for it again and I'll let you take it. Or if you wait the full 6 months, I'll let you take it again for free. You know, but we want people to really, really want it or to go after it. You know, again, we make enough off these to maybe pay for some of our technology in the tester software. That's about it. So,
It's not like you have to complete a certain set of exams before you
Yeah, so he's asking about what it takes to qualify for CSWE. All of our exams, with the exception of CSWE, there's no prerequisites. To be able to take CSWE, you have to pass CSWP, and then 4 of the 5 advanced topics. So we're talking drawings, drawings, mold making, sheet metal, weldments, and surfacing. Okay, it used to be the mold making one used to be called mold tools. We changed it. We finally updated and changed it at SolidWorks World. Now called mold making. It's probably the most difficult exam we have now. If you're not a mold maker or not familiar with the mold making industry, you can't pass the exam. So we're trying to introduce these industry focused exams because we've had sheet metal for a while, right? And if you don't know what bin tables are, bin radiuses, stuff like that, it would be tough to pass that exam. And even with weldment, there's like weld gaps and things like that that you need to understand. So you have to pass 4 of those 5 exams. And then at that point, you've met the prerequisites to take CSWE. And then inside the new CSWE, it actually grabs different challenges from some of those exams and uses that similar functionality inside of them. So even if you skip surfacing, which a lot of people used to do because it was the most difficult, you would encounter a surfacing problem inside the CSWE exam. So to us, expert is somebody who knows enough about most of the parts of the software to find his way through a problem. He's the person that when you have a problem, like, how do I do this in SolidWorks? That's the guy you go ask. And like on that spring question, you say, how do you make the spring? It says not to use a helix. What do I do? Okay, so that's the guy that really is the CSWE.
It never gets into stuff like PCB or bolt or...
No, so he's asking what else it gets into. We have a PDM administrator exam. We haven't done anything with PCB yet. So those are all separate things. We try to keep the prerequisites to the main areas, quote unquote, of the software. So PDM and PCB, those are like outlying products that not everybody has access to. Everybody can do surfacing, sheet metal, mold tools, drawings, and weldments. It's in the base software.
Since you can't talk about what's in it, you can talk about what's not.
Well, the part we just modeled earlier is not in it, but it's just so I basically if you go to this the website here, let me just quickly get back to it. There is some information on here. You're going to want to be familiar with these topics that are listed here. Probably the one that we get a lot are sketch blocks and belts and chains. Okay. So sketch blocks, a lot of people, they may not use, but if you go and search in like on YouTube and looking for sketch box or sketch blocks, you can see the why or how that functionality may be useful in day-to-day work. Especially if you're doing like mechanisms that have to move with each other, sketch blocks are perfect for it. I mean, you can sketch a mechanism and see if it's going to work before you even start extruding it. And then you take that sketch, those sketches, and you can start extruding those profiles into parts. So think of like a front end loader, like a tractor, right? That mechanism that keeps the bucket kind of, parallel to the ground. You can sketch that whole mechanism and see if it's going to work and tweak it until it's just right, and then start extruding things. So sketch blocks, stuff like that. 3D sketch is not heavily used. It's more tied to weldments. So that was added in the new version a couple of years ago. Same with bill of materials, and then the sheet metal stuff that was added in there. So, but as long as you're on here, if you're familiar with that stuff, is helpful in there. And then just again look online, and if you have any questions, write to us and say, hey, is there anything else I should really? This is what I'm familiar with. Should I be there? You'll be surprised during the exam. That's for sure. You'll be like, whoa, I didn't expect this. But at that point, you're so good with the software, you're just kind of start figuring ways around it. So we have about 20 minutes. I think I can get through a really quick surfacing problem if you guys want to try it.
Let's do it.
So I don't know how many, if anybody's using surfacing in here. It's a couple of people. So I'd like to call it the black magic of CAD. It's like this really crazy tool that a lot of people won't use, but there's some things that you can use for surfacing, or you can use surfacing for, that you just cannot do with just solid tools. All right. And this is one that kind of came to me through just like kind of by chance to say, hey, how would you fix this? And then I said, and then I thought to myself, hey, can I use this model for something else? And I turned it into a presentation. All right. So this is a classic example of an imported part. Okay, people might go to like Thingiverse or different file sharing or model sharing sites and download. This is just a simple dust cover for a network. Is that a RJ45 jack or whatever it's called? And they just need it to for something. All right, but if we look closely in here, there's an issue with this part. See that little face? I like to call it the tent face. Okay, so if I was going to build a mold for this and I would use cavity feature and everything else, guess what's going to happen? That's going to replicate into the cavities. Then the CNC guys, they're going to replicate it into their CAM program, and the machine's going to try and cut that little thing. Then it's going to cut it, and it's going to get molded in that part that's going to be on the part.
They're gonna call you and say,
It's, hey, what's wrong with this? All right. So this is a kind of a classic example of how to use surfacing. Okay. We've tried multiple ways when I do my surfacing presentation, we've tried multiple ways to fix this with like cut extrudes, any kind of solid features, and we were never able to get it right. Okay. So the fun thing about this, or the nice part about this, is that the error is also mirrored on the other side. Okay. So what happened is this is probably created in another CAD program, probably not SolidWorks, and that's why it created the error, right? Because those other CAD programs don't work, right? And they mirrored it and it carried over. So let's go through and fix this really quick. Again, now I haven't done this part probably about 6 or 8 months, so we'll see if I can remember how to do it. And luckily I have my features here if I get caught. So this is the way I would fix this, right? And I'll try to caveat it as I go through and why I do things, okay? So my process for fixing parts was to get rid of the bad stuff, then patch it, and then make it whole again. That was my 3-step process. All right, so what I'm gonna do is I'm only gonna work on this side. We can see that basically this surface should carry all the way up over to that surface, right? It should be a nice linear face on there. So let's start working on this. So I'm gonna work on I'm cutting away the bad stuff first. So I'm gonna start by sketching up here, okay? Completely backwards, right? What the heck are you, why you're sketching up there? But I'll show you why. So I'm gonna grab my line tool and I'm gonna grab, from that endpoint, I'm gonna do a horizontal line there. And from that endpoint, just a horizontal line, and it can just be anywhere out in space. I don't care where it ends, as long as it gets past that edge right there. So then I'm going to go insert. I don't have this on my toolbar. Insert reference. No, what am I looking for? Split line. Insert surface split line. Okay, now I got to remember where it hits. Where to find split line. So I can go up here. I can go split line. I don't know. Spelled split wrong. Split line. There we go. So this is really cool command shirts. I can click on this little eye right here, and then it'll take over and it'll actually show me that that's already on my mold tool. So it's there. So it's somewhere up inside here. If you don't have it on your toolbar, the command will show you where it is in the pull downs as well. So insert split line projection. It's just going to project the current sketch onto this face and onto this face. And then we'll click OK. What that's going to do is it's going to basically take those lines and project them down onto those faces and split them. So now what that does is if I creatively rotate and zoom in here, I can grab these 3 faces now, and then I can right click and I can delete them. But you need to choose the right delete. There's 3 deletes on this table. Okay. Let me go up here where there's a little more room. Okay. We can delete a face, a feature, or a body. Okay. We don't want to delete the body because the whole thing will be gone. Same thing with the feature. Well, there's no feature there, so it'll probably delete the body as well. So we just want to delete the face. Okay, we've tried delete and patch, delete and fill. It gets close, but it's not continuous geometry. We still see a line there. So I'm going to click delete. All right, so now if we look and if I can creatively rotate around, we're actually looking inside that body or that model now. Okay, this is the crazy part about surfaces. This is no longer a solid body. If you look over here on the left, there's no solid body. It's now a surface body. I clicked the back side of that face and it highlighted the front side of the face. Okay, so surfaces have no thickness to them at all, but they don't really exist, but you can use them for a variety of things. This is where the confusion of surfaces really starts to come in for people because it just doesn't make sense. All right. So I've created that. I've cut it away, and now I need to patch some things. There's one more issue we need to look at here, and this is going to show us that on this surface up here, because that little tent shape, we have that little bridge there, or tent kind of shape. So we need to patch 3 surfaces. Now, the next step I would do is I want to grab these surfaces and I want to isolate everything else. So I can just kind of work on and focus on the area I need to focus on without having to look at other things. So what I want to do is I want to copy these surfaces and then turn off all the rest. That way I just have those two surfaces floating. I can rotate them around and cut things and extend things without having to do sections and all these other things, just so I can select things from the right side. So unfortunately in SolidWorks, there's no visible copy surface feature. All right, if you search for it, it doesn't exist, all right? But I'm gonna show you where it's at. So on my surfaces toolbar, I'm gonna do an offset. I'm gonna do a surface offset. So offset surface, okay? And you can see it defaults to 0, or I'm sorry, to 100. That's just what it defaults to. And you can see it's offsetted. Right here it says offset surface, right? Watch when I type in 0 and hit enter. It changes to copy surface, okay? Now at one point in time in SolidWorks, you couldn't offset a 0 distance, because if you offset 0, are you really technically offsetting anything anymore? Not by definition, right? So it wouldn't let us do that. So what we do is we'd offset it 100 thou one way, click OK, then take those surfaces and offset them back 100 thou the other way. All right. And then some genius at SolidWorks discovered, hey, let's just add a copy thing. So that's how you find copy surface in SolidWorks. Click OK. And now we have a variety of surfaces in here. See, there's our main one there. I'm going to hide this. Okay. And what you see we have left is basically just those two surfaces. I've turned off everything else and I can focus on the areas I want to just kind of work on. So at this point, it's basically just extending some surfaces. So I'm going to grab extend surface, grab this edge. I don't care about the value as long as it penetrates beyond that other surface. We'll click OK. And then I need to extend this one beyond there. So again, once extend surface, I'm just going to grab these edges. There's a couple of options when you do extend. Basically, we want same surface. Linear would actually take it, just kind of put it for a linear from that point. But when we do a same surface, what you'll notice is that we don't end up with any artifacts of where that surface began and ended previously. So now we know we've taken that surface and we've kept the intended geometry flow, if you will. It's still what it was supposed to be. So now it's just a matter of trimming. I'm going to trim this surface to this one. So trim surface here. The trim tool is going to be this body, and then keep or remove selections. It doesn't matter as long as you can get to one or the other. So if I want to keep selections, if that's the one that's enabled, I want to select this one out here and click OK. Now, can you guys all see that the red lines? I've changed my default setting to have open surface edges show as red because they stand out. All right, I forget what the default color is, but red is just a glaring color. It's very high contrast. All right, so there's that surface there. The next thing is we need to trim away the other way. So this is going to be a trim as well, but it's a mutual trim. All right, so this is going to be, the trimming surface is going to be this surface. And then on here, let's see, why is it not, I'm sorry, is this maybe just actually probably just standard trim? It's just a standard trim, I'm sorry. Again, I haven't done this for a while. Remove selections, we're going to remove this one. There is a point where we do a mutual trim, but I think it comes up later on. So now we can see what happened there. See, we have a nice little red line there. Everything kind of matches up the way it's supposed to. All right, so let's go back and let's turn on our original body and we'll show it. And now as you look in there, things are looking like they're supposed to. Okay. Unfortunately, on this here, let's turn these off. Or not unfortunately, but control select those. I'm going to hide them for now. We still have the original geometry that's there. Now, we don't really need it, and you can use it as, you can just leave it as reference geometry, but I like to consume it. So I'm going to right click, I'm going to control select these, right click them, and then delete the face. Again, not the feature, not the body, but the face. Delete, and then click OK. All right, and when we turn these back on, you see there's a big hole there. We show these again, now it's patched. But there's one issue, and this, as you can see, is looking at our red line there. See right around there? So it's a broken red line because that surface is extending down through there. All right, so this is just another trim, and this is where keep feature or keep surface versus remove surface is very handy. So in this case, the trim tool is going to be this surface there, and then I'm going to want to use keep because I can't get to the point where I want to remove. It's buried below. So I want to keep that there, but I also want to keep these two over here. Otherwise, it'll get rid of those. Click OK. What did I do here? Mutual? No. Whoa. Let's try that again. Trim surface. This is going to be my trim tool. Remove, keep selections. Let's try that. Yeah. Oh, that's why. Okay. Okay. So the reason it would happen is I didn't need to select these out here because there's still two different surfaces. So what it was telling me is that this surface doesn't actually intersect with there. So why, what's the problem? The software is yelling at me saying, hey, you're doing something wrong. Okay. Now, as I look around there, you see a nice red line around everywhere. So let's go ahead. So the last final thing is that back in the day, to create a mold for this, to use a cavity feature, you couldn't use a surface body. You need to have a solid body. For a surface body to become a solid, it has to be watertight. There can't be any gaps in there. Now, there is gap control now. You can allow some, but wherever there's a gap, when you use a cavity feature, it's going to shoot like solid bodies into that area. All right. So now it's just an issue of knitting these things together. So knit surface, I'm going to select these 3 surface bodies and click OK. There used to be here, it says create solid. In your 2016 version, if you go back and look at it, it says try to create solid. And I thought that was the best kind of feature nomenclature we had. And I thought we should put try to on everything. Try to extrude, try to cut, because it's like a disclaimer at that point, right? Hey, this may or may not work. So unfortunately, in 2018, they changed it and just says create solid. So create solid. In this instance, we should have no, in fact, we can turn off gap control and it'll create a solid. And so we're back to a solid body. At this point, what I could do is, in fact, we can try and do it. Let's see. We'll use the right plane to cut. Let's see. Let's just do. Let's do this. Let's do this.
You just delete those faces and mirror the surfaces to the other side.
Yeah, and then you have to do some trimming and stuff as well. So we asked if can we mirror the faces over and then do that? But everything you do on one side, you have to do again on the other side. So what we're going to do is basically I'm going to cut this in half, and I'm going to go through both ways, and then basically take on my right plane, and I'm going to go to features, then mirror. I'm going to bodies to mirror is going to be this body, and click OK. And the nice thing about this is it actually doesn't create a mirror line down the center. Yeah, it actually merges it, and you can see that the patch is done really nice on both ways. So again, there's a whole nother, maybe I'll come back sometime and do the surfacing presentation. I'm guessing you guys, because there's some ID guys in here, right? And some of the stuff you guys create it's not blocky like the part we did earlier. So you guys probably have a lot of guys that are doing surfacing already. I could probably learn a thing or two from. But when we got to user groups and stuff like that, people do not want to use surfaces. They're scared of it, but it's just really cool tools you can use in surfacing. So unless there's any questions online, that's about it. I know we're about 10 minutes early, but I'm sure people either want to go home or have meetings they need to run to at 3 o'clock.
Everybody wants to go home.
Yeah. So this is kind of late in the day for you guys, right? So I still got to get into the city this afternoon somehow. So and then do it all again tomorrow.
My team also offers internal training. If you guys are familiar, we're basically X-Central. Large measure surfacing class, maybe at least once a month. You can access it. I'll send out invites to everybody, and I'll send out the information. Like this, go/X-Mechanical, and then there's a training section, and we actually have videos from all the previous training sessions that we've had that are easy to go along with. Lots of information in there for X actually. So, cool.
All right. Any other questions in here in the room? No.
Questions on that?
And so is everybody going to attempt CSWP before we come back for the next time? At least try it.
Definitely.
Yeah, give it a try. It's again, don't feel bad if you don't pass it the first time. I didn't pass it the first time I took it. So honestly, if I had to take it today, I think I would struggle with it. I just don't use the software as much as I wish I could. But it's fun stuff. So we love it.
So did you spend some time talking about automation? So like macros, automation, automatic stuff, like for example, how we saw that knit. You had like a huge build and you just wanted something to be like, all right, scan this whole thing, find all these problems.
Yeah, so he's asking to talk about spend some time talking about automation, stuff like that. API and all that stuff are probably like the worst areas of software to ask me about. Unfortunately, it's just one of those things. I know you can do some really cool things with it.
Is there like a repository where
Yes. So, yep. MySolidWorks.com and the SolidWorks forums, the user forums. So the SolidWorks users forums have for a long time I think it's forms.solidworks.com. If you just search for SolidWorks forums, there's always, I think it's at least like 1,000 people active every day on there. And there are API forums. People share APIs and they talk about them. So if you're looking to do things like that, somebody will help you. The other thing you could do is we ran into what's his name from Hawkridge, who's on campus today. If he doesn't know, he could put you in contact with somebody from your reseller that can. So you guys are probably paying for maintenance, and that's what those guys are for. They're there to answer those questions and help you with things. And usually they have API guys that if you have something specialized you want to do, they could probably on a consultation basis help you develop and write those APIs. So I've heard the API stuff is really dynamic for the people who use it. I just don't.
Yeah, I mean, I've seen some stuff and it blows my mind.
I bet. Yeah. And then yep. And the other option too, maybe, and Monty, maybe you and I can talk offline about this, is our product definition team. They go out and do like visits at customers looking to see like what their needs are. And these are the guys that write the specs for the upcoming versions.
Because really what's been happening is just people kind of go at it like a game of attrition. You know, like here's a complex problem. Let's just get like 5 engineers on it instead of one person who knows the APIs. You know?
Yep.
And that's just been like the industry solution.
Yeah, whenever we run a survey asking what people like an exam in, usually the number 1 or number 2 response is API.
Okay, cool.
So it's not like this kind of like, niche area. It's pretty popular. So otherwise, thanks to everybody online. I don't know if they're still there or not, but yeah. So and thanks to everybody else who was here.